Welcome to Unacademy, the largest online e-learning platform. Good morning, Chandrakiran. Welcome to Unacademy. So, we were discussing network analysis and transmission lines crash course and lecture 8, a representation of lecture 8. It is response of RC series circuit. Yesterday we have seen low pass RC circuit. Today we shall be discussing high pass RC circuit. Today we'll be discussing high pass RC circuit. Before that, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and also cracked GATE. And let me also explain you the Unacademy Learning App installation procedure. Type Unacademy Learning App in Play Store and click on install. Then you can click on this GATE and engineering services if you are opting for GATE and engineering services, and click on this plus and click get subscription. You have plus and iconic subscriptions. You can use my code as YSK10 to get the maximum discount and click on this proceed to pay. You'll get a dedicated mentor for your preparation in iconic subscription, and when you click on this proceed to pay, you'll have the payment gateways like debit card, credit card, EMIs, UPIs, wallets and net banking. Using any of these payment platforms, you can get subscribed to Unacademy, the largest online e-learning platform. Let me tell you about Evolve GATE 2022 Electrical Batch A, English and Hindi. It has already started in December 21st. We have Ankit Goyal sir, Ajay Gupta sir, Hafiz sir, BV Reddy sir, and Suresh VSR sir, the top educators of Unacademy who will be handling subjects for you. And it's very benefit for the students to get enrolled for Evolve GATE 2022. So let me also tell you about the Unacademy Combat, which is India's largest fortnightly competition for GATE. The best questions by the best Unacademy educators. So there will be challenging questions curated by our best Unacademy educators and questions guaranteed to keep the test engaging, challenging as well as fun. So super fast and fun with real-time ranking. See how you rank against others with a live leaderboard after each and every question. So compete with the best, know where you stand among all other contestants. You'll get a detailed video solutions by the top educators. You'll get in-depth video solutions for the questions right after the contest. And you'll have the score, leaderboards, rating and awards. So compete, crack and conquer. The awards are something like this. Compete with the best and win amazing prizes. The first three rankers will get 3 months subscription to Unacademy or an equivalent Amazon voucher. And you have 500 rupees worth Amazon voucher for 4th to 50th rank. So to tell you about Unacademy Combat, you have to compete, crack and conquer. It is India's largest fortnightly competition for GATE. You have challenging GATE questions created by best educators, super fast and fun with real-time ranking, compete with the best, detailed video solutions by the top educators, and you'll win exciting prizes as I told you for rankers 1 to 3. We'll get 3 months Unacademy free subscription, which is very great, and you'll have get an ESE subscription or an equivalent Amazon voucher, and from 4th to 50th rank you'll get 500 rupees Amazon voucher. So enroll for free. Next combat goes live on December 29th 6 p.m. So please do register for this competition, and you can use code crackgate to unlock it, or you can also use my code YSK10. So the competition format is something like this. The competition format is 60 minutes competition with 15 questions and 4 combats and 3 cohorts. So relative scoring will be based on the speed and the accuracy of the students. So enroll love in Unacademy Combat. To participate in Unacademy Combat, sign in on Unacademy Learning app. Use my code YSK10. You can get into Google Play Store and install it. So before going to our next topic for today, let me tell you about, just give you a brief idea about this. The new batch Evolve for GATE 2022 and Ascent for GATE 2023 has started from 28th of December. We have top educators of Unacademy, so hurry up, get subscription now. So that was about the Evolve and Ascend GATE 2022 and 2023. So the topic for today is response of RC series circuit. Shivakumar, good morning. Welcome to Unacademy. So the response of RC series circuit, will be discussing that today. So let us consider response of RC series circuit. As I told you yesterday, you have a resistor and a capacitor. Either you can connect it like this, or you have a capacitor and a resistor. Now when you consider this R and C and take output across the capacitor, it is a low pass RC circuit. This is V input, this is also V input, capacitor, resistor, and V output. Now if you take voltage output across resistor, it is RC high pass circuit. This is RC high pass circuit, and this is RC low pass circuit. I've also told you this, why do we get this? And so we are considering this part today, RC high pass filter. You'll also get the same response, but this will act as a differentiator. So let's discuss first response of this RC series circuit. Let's discuss the response of RC series circuit. So let us consider the response of RC series circuit. So what is this response of RC series circuit? You can consider an RC series circuit. A high pass RC series circuit. This is Vi, capacitor, resistor, output is taken across this, and let us consider there is I of t, and we are doing it for, let us say, step input. So the input is step signal. You have a step signal like this. So Vi of t versus t. So to this circuit, we will supply input with a switch Vi with a switch that is operated. This is switch K. Now at t is equal to 0 minus, at t is equal to 0 minus, what is our switch? Switch is off. At t is equal to 0 minus, switch is off. So when the switch is off, we can say there is no flow of current. There is no flow of current, right? When the switch is on, you can draw the diagram. This is the input, and switch is off. You have a capacitor and a resistor. This is Vi. The switch is off, capacitor and a resistor. When you have this, what is the flow of current in this I? So I of 0 minus is equal to 0 amperes. Now let us consider at t is equal to 0 plus. What happens at t is equal to 0 plus? You have this, you have input voltage and switch is on. you have capacitor and a resistor. In this case, if you observe, the capacitor does not allow sudden change of voltage, so it will become a short circuit, and you have current in this with a resistance V input. In this case, current at I is equal to 0 plus will be VI by R. But if you observe the voltage across this capacitor here, VC at 0 minus is 0 volts. And also if you observe VC of 0 plus is equal to 0 volts. Capacitor does not allow sudden change of. Soumya, good evening. Sorry, good morning, Soumya. And Shweta, good morning. So you have I of 0 plus and V of 0 plus at t is equal to 0 plus, and at t is equal to 0 minus also you have I of 0 minus and V of 0 minus. So now let us consider at a t greater than 0. Let us consider at t greater than 0. What happens? You have the input voltage and switch is on. There is a capacitor with a resistor R, C, Vi. Now if there is a flow of current, what is Vi is equal to I into R plus 1 by C integral I dt. What is Vi? Vi is a step input. Vi is a step input. So when Vi is a step input, when you have Vi as a step input, Vi is equal to I into R plus 1 by C integral I dt. So you want to make this equation as a differential equation. So differentiate with respect to t. You'll get step differentiation as 0, constant being it, and R into di by dt plus 1 by C into I. Okay, this is one way of doing it. You can also write it as di by dt plus 1 by RC into I is equal to 0. The solution of this differential equation is solution of this differential equation is I is equal to IC plus IP. I is equal to IC plus IP. Now when you want to do this, so you want to find the solution IC. So to find IC, you can write the differential equation as D plus 1 by RC into I is equal to 0. From this, consider auxiliary equation f of m plus 1 by RC is equal to 0, m is equal to minus 1 by RC. So what is IC? IC is equal to k into e power minus 1 by RCT. So we got IC is equal to k into e power minus 1 by RCT. But what is the time constant of an RC circuit? It is RC. Therefore, IC is equal to k into e power minus t by tau. This is IC. To find IP, you need RHS. Since there is RHS is equal to 0 in the given differential equation, in the obtained differential equation, IP value will always be 0. Therefore, I is equal to IC plus IP. So I is equal to IC, k into e power minus t by tau plus 0. Therefore, I is equal to k into e power minus t by tau. In this, you need to find what is the value of k. So to find k value, what do you do? To find k value, in order to find k value, so what I got, I is equal to k into e power minus t by tau. So at t is equal to 0 plus I of 0 plus value is vi by r. This was what we have seen here just now, right? So if you just see here, yeah, this one here, I of 0 plus is equal to vi by r. Therefore, if you substitute it, I value is vi by r is equal to k into e power 0 by tau. So this will give you K is equal to Vi by R. Therefore, substitute K value in this, you'll get I is equal to Vi by R into e power minus t by tau. This is the solution that you get. Funny, good morning. Now let us try to find what is the value of voltage across resistor. What is the voltage across resistor? V R is equal to I into R. What is I value? Vi by R into e power minus t by tau into R. So R and R will get cancelled. VR is equal to Vi into e power minus t by tau. So this is the voltage across resistor. Now let's try to find what is the voltage across the other element in the circuit. Voltage across capacitor. What is the voltage across capacitor during a finite time? So it is Vc is equal to 1 by C integral I dt from 0 to t, from some value of 0 to t. Now if you consider that, what is Vc is equal to 1 by C integral, what is I value? Vi by R into e power minus t by tau dt. So you will get it as Vc is equal to 1 by C into Vi by R if you take out into e power minus t by tau integration. Integral e power minus t by tau dt. So let's write that Vc is equal to, what is Vc is equal to 1 by C Vi by R e power minus t by tau integral e power minus t by tau dt. So Vc is equal to 1 by C Vi by R into integral e power at. Integral e power at is e power minus at. E power minus at integral is e power minus at by a. You'll get e power minus t by tau by minus 1 by tau, which is the coefficient of t. So we'll write it as Vc is equal to, this is from integral from 0 to t. So this is from 0 to t into Vi by R into, I'll just take minus tau to the numerator. If you take 1 by tau into e power minus t by tau from 0 to t. So what you'll get it? Vc is equal to 1 by C into Vi by R into, what is minus tau? Minus Rc. So Rc, R and C will get cancelled. And if you apply limit e power t, e power minus t by tau minus e power 0, 1. So Vc is equal to minus Vi into e power minus t by tau minus 1. So Vc is equal to Vi into 1 minus e power minus t by tau. This is the voltage across capacitor for t greater than 0. Right? So we have obtained what is current, what is the voltage across resistor and voltage across capacitor. So these values of current in the circuit and voltage across the resistor and voltage across the capacitor can be written like this. So what is current in the circuit? What is the value? I is equal to Vi by R into e power minus t by tau. Voltage across resistor. What is the voltage across resistor? Voltage across resistor is VR is equal to, just look at what is voltage across resistor, Vi into e power minus t by tau. Vi into e power minus t by tau. Now voltage across capacitor. Voltage across capacitor. What is the voltage across capacitor? Just look at that. Vc is equal to Vi into 1 minus e power minus t by 2. Vc is equal to Vi into 1 minus e power minus t by tau. Now if you observe exponential values at a t is equal to, for all these three, at a t is equal to 0, at a t is equal to tau, at a t is equal to 2 tau, at a t is equal to 3 tau, at a t is equal to 4 tau, at a t is equal to 5 tau, and so on. If you observe, this value is a decreasing function, this is also a decreasing function, this will be an increasing function. Now let's try to plot them. Current versus time. This is current versus time. This is voltage across resistor versus time. This is voltage across capacitor versus time. So this value is I versus T. This is VR versus T. VC versus T. So this is at T is equal to 0. At T is equal to 0, it is Vi by R. So this value will be Vi by R. It is a decreasing function. And this how much it will decrease will depend upon this tau value. And here Vi, voltage across resistor, if T is equal to 0, its value is maximum T Vi, and it also decreases. And voltage across capacitor is an exponentially increasing function. So this is the current in the circuit, voltage across resistor, voltage across capacitor, and their plots. So let us look at some problems. Before that, let me tell you, RC high pass circuit as a differentiator. Now let us draw that. This is a capacitor and a resistor, Vi, C and R. There is some flow of current in this I of t. If you take the output across this resistor, V output, which is also equal to voltage across resistor. Now in this, if you observe, if time constant of circuit is very small, what happens because of this? Capacitor charges quickly, and there is negligible drop across resistor. The total voltage will get dropped across this capacitor. Now if you observe the other point, therefore the current in the circuit, because it is the voltage which is dropping more across the capacitor is charging quickly, current in the circuit is because of voltage across the capacitor that is flowing. Now what is Vi is equal to Vc plus Vr. As we know that the time constant is very small, tau is very small, Vr is very less, so V input is equal to voltage across capacitor. Now what is voltage across this? V is equal to Vc. Vi is equal to Vc. What is the output voltage that you can write? What is the output voltage? V output is equal to V voltage across resistor is equal to I into R. Now just now we told that current in the circuit is because of the voltage, therefore I is equal to, can I write I is equal to C dVc by dt. So you can write this as V output is equal to C dVc by dt into R. So you can write this as RC into dVc by dt. So what can you write from this? You can say that output voltage is proportional to dVc by dt. That is, what is Vc as I told you? Because Vr is negligible, Vc can also be written as Rc into dVi by dt. That is, or you can write it as dVi by dt. So output is proportional to the differentiation of the input. So that is the reason it will act as a differentiator when the time constant is very small. Now let us consider a step input. The input is step, or let us consider the input is triangular. So input Vi, Vi versus T and Vi versus T. So in this case it is step input, it is triangular input. Now in this case the output will be, because the voltage across capacitor drops, the volt capacitor charges quickly, voltage across resistor output voltage will drop very fast like this. So this is the V output voltage with respect to T. And if you consider an triangular signal as an input to this high pass RC circuit, you will obtain a square wave. The output is a square wave. So this is V output with respect to T. So for a very small time constant, a high pass RC circuit will behave as a differentiator. So let's see what we have seen here once again. So if the time constant of the circuit is very small, capacitor will get charge will charge very quickly, and there is a negligible drop across this resistor. So I have assumed that it is V input is equal to Vc plus Vr, where Vr is very small, negligible. So we can write Vi is equal to Vc. The total voltage across will drop across the capacitor, and therefore the current in the circuit is because of Vc. So V output is equal to voltage across resistor is I into R. So I is because of capacitor, so I is equal to C dVc by dt. So V output is equal to C dVc by dt into R. So RC dVc by dt. We can say that the output Vc by dVc by dt can also be written as dVi by dt, because Vi and Vc are same. So the output voltage is proportional to the differentiation of the input. So if you give a step input, you'll get a spike or an impulse like this, and this value of response will depend upon the tau again. And if you give a triangular input, the output is a square. So this is how a high pass RC circuit will behave as a differentiator. So after this, let us consider some problems to solve them. So I'll consider one problem. So the given question is, for the network shown, switch is open for long time and closes at t is equal to 0. For given network, switch is open for long time and closes at t is equal to 0. Determine voltage across capacitor Vc. Determine Vc of t for t greater than 0. So the given circuit is like this. There is 1200 volt supply and a resistor. There is again a resistor here and a capacitor of 50 microfarad. So let's write these values. This is 1200, resistor is 100 ohms, switch is given, it is closed like this, and 300 ohms, 50 microfarad. So when you try to write at t is equal to 0 minus and t is equal to 0 plus, let's see what you'll get. So what is t is equal to 0 minus? Switch is open. When switch is open, it is connected to capacitor and capacitor is completely charged and capacitor will become open circuit. So at t is equal to 0 minus, let's try to draw the circuit. Switch is already at t is equal to 0 minus since long time. So you'll have a resistor, switch is open. So you need not consider this resistor also, and this capacitor will become open now because it has been charged already. And what is the voltage across this capacitor after it is charged? It is Vc of 0 minus is equal to 1200 volts. To 1200 volts it will get charged, right? So because it has been connected to supplies for a long time, so Vc of 0 minus will be 1200 volts. Now let us consider t is equal to 0 plus. At t is equal to 0 plus, also in capacitor does not allow sudden change of voltage, so Vc of 0 plus will be 1200 volts, right? So for t greater than 0 we need to draw the circuit. For t greater than 0, so let's consider the circuit. You have 1200, 100 resistor, 300 and 50, and switch is closed in this case. So here also switch closes at t is equal to 0 plus, switch is on. At t is greater than 0, also switch is on. Let's draw that. So 1200 volts, 100 ohms, switch is connected. You have 300 ohms and a capacitor of 50 microfarad. So let's write all these values. It is 1200 volts, 100 ohms, 300 ohms, 50 microfarad, and across this 50 microfarad that you have Vc of t, and switch is closed here. The switch is on. Now let's try to apply KCL. Apply Kirchhoff's current law. When you apply Kirchhoff's current law, what is the voltage here? Let's say this is Vc. So let us take this current as entering, this current as leaving, and this current as leaving. Consider these current values as, let's say, Ix, Iy, Iz. So we can write entering current Ix is equal to leaving current Iy plus Iz, right? So Ix is equal to Iy plus Iz. Now what is Ix? It is current from 1200 to Vc. So it is 1200 minus Vc by 100 volts, V by R. Iy, Vc minus 0 by 300. Nodal analysis. Now this is C dVc by dt. I is equal to C dVc by dt. You need to write this C value as 50 microfarad. So let's write that. So this is 1200 by 100 minus Vc by 100 is equal to Vc by 300 plus C value 50 into 10 power minus 6 dVc by dt. So if you simplify this, you'll get dVc by dt plus 266.67 Vc is equal to 0.24 into 10 power 6. So this is the differential equation that we get if you just try to simplify that. So this is the differential equation, and you need to find the solution of this differential equation. So let's try to do that. So I'll write the differential equation and let's try to find its solution. So the differential equation is dvc by dt plus 266.67 vc is equal to 0.24 into 10 power 6. 0.24 into 10 power 6. So what is the solution of this? V is equal to V complementary plus V particular integral Vc. So how do you find this complementary? To find the complementary function, you need to consider the auxiliary equation. So this is, you can write this equation as d plus 266.67 Vc is equal to 0.24 into 10 power 6. So you can write as m plus 266.67 is equal to 0, or m is equal to minus 266.67. M is equal to minus 266.67. So it is minus 266.67. What is the solution? V complementary is equal to only one root. So k into e power minus 266.67 t. Next we need to find the particular integral. So let's try to find this particular integral. To find V particular integral, how do you find? RHS is equal to, we'll write this differential equation here. We'll write D plus 266.67 into, we'll write VC particular is equal to 0.24 into 10 power 6. So what is V particular? Let's call this as V particular instead. 0.24 into 10 power 6 by 266.67 t plus. So we do not have anything here, so we need to write e power 0 t. So substitute d is equal to 0, then we will get vp is equal to 0.24 into 10 power 6 by 266.67. So let's try to evaluate that. 0.24 divided by 266.67 into, so this will give you 899.98 equal to 899.98. You can approximate it to 900. So we have to write the total solution now. What is V is equal to VC? V complementary plus V particular integral. What is complementary? VC is equal to K into e power minus 266.67 t plus VP is 900. But you still need to find K. So to find value of K at t is equal to 0 plus VC of 0 plus value. What was the VC of 0 plus value? Let's look at that once. VC of 0 minus VC of 0 minus is 1200. VC of 0 plus will also be 1200. I guess VC of 0 plus is also 1200. So VC of 0 plus is also 1200. So let's try to write that. It is 1200. So if you substitute that value here, if you substitute this value here at t is equal to 0, so at t is equal to 0, VC is equal to 1200. So 1200 is equal to VC is equal to 1200. K into e power minus 266.67 into 0 plus 900. So K value will be, anything power 0 is 1. So K is equal to 1200 minus 900 This will give you 300. Therefore, what is the total solution now? Vc is equal to k into e power minus 266.670 plus 900. Therefore, Vc is equal to k. What is k? 300 into e power minus 266.67 plus 900 volts for t greater than 0. This is the solution. This is the value of voltage for t greater than 0. This is how you will find. So let's see how we have done this once again. So this is the question that is given to us. The switch is open for a long time and closes at t is equal to 0. Determine Vc for t greater than 0. So when switch is open at t0 minus, we have written the voltage across the capacitor as 1200 when the switch is open, because it is closed. The switch is, this is open, so the capacitor is directly connected to this 1200 volts for a long time. Therefore, this Vc of 0 minus will be 1200. Next, as the capacitor does not allow sudden change of voltages, Vc of 0 plus will be 1200. So for t greater than 0, the switch is already on. Then we try to consider this circuit, and we have applied KCL and we got a differential equation. And in order to solve this differential equation, we have considered complementary function, particular integral. You can also solve it by using linear differential equation, dy by dx plus p into y is equal to q or so. So I have considered this method of complementary and particular integral. I got complementary function as k into e power minus 266.67 and particular integral as 899.98 or 900. Then we have written what is Vc, k into e power minus 266.67 plus Vp is 900. Then we need to find what is k value. So to find k value, we have substituted the initial condition. What is the initial condition? At t is equal to 0. Krishnachari, good morning. Welcome to Unacademy. At t is equal to 0, Vc is equal to 1200. That is what we got it. We have obtained it. So we'll find k value and get it as 300. So once you get the value of k, substitute in Vc. So that will be the voltage across capacitor for t greater than 0. This is how you will determine the voltage across capacitor. Now let's also solve one more problem. The question given is this. In the network shown, switch is shifted from if switch is shifted from A to B at t is equal to 0. Therefore, it is at A for a long time. Determine V of t or find V of t for t greater than 0. And the circuit is given like this. See, there is a 5-volt source that is given. There is A and B, and you have a switch, a capacitor, and a resistor. So let's write these values. This is 5 volts and switch is moved from, this is position A, this is position B. It is moved. It is made a source free circuit. Simple, right? When it is at A, it is connected to source. When it is at B, it is a source free circuit. So the capacitor will start discharging. So 1 by 4 farad. This is 2 ohms, and we are asked to find voltage across this resistor for t greater than 0. So let's try to find this. So at t is equal to 0 minus, let us consider at t is equal to 0 minus. Where is the switch? Switch is at position A. When the switch is at position A, let's try to draw the diagram. So this is the diagram that is connected here. You have this capacitor, and this capacitor is connected to the source for a long time, so this will become an open circuit, which will the capacitor will be a open circuit. And you have a resistor here, and you need not draw this because it is a B terminal. You need not draw this resistor. Even if you draw, that doesn't matter at all. So this will be 5 volts. So what is the voltage across capacitor? It is 5 volts. Is charged to 5 volts, and this is V of t and 2 ohms. So let's write what is voltage across capacitor. At 0 minus, it is 5 volts. Now what is the voltage across 2 ohm resistor? It is 0 because it is 0 volts. At t0 minus, let us consider at t0 plus. Now at t0 plus, capacitor does not allow sudden change of voltage. Now capacitor will act as a 5 volt source. This capacitor will act as a 5 volt source when this is disconnected from this A terminal and it is connected to B. So the circuit will be, if this is B terminal, this capacitor will start acting as a voltage source of 5 volts, and there is another resistor. So here if you observe, this is capacitor that is acting as a 5 volt source. This is 2 ohms. Also here V of 0 plus it is, and this is 2 ohms, and there will be a flow of current I of 0 plus. So what is I of 0 plus now? I of 0 plus is equal to minus 5 by 4, that is minus 1.25 amperes. Voltage by resistance, total resistance is 4 ohms. What is V of 0 plus? The voltage across this, it is minus 1.25. V is equal to I into R. R value is 2. It is minus 2.5 volts. V of 0 plus according to the given terminals. That is minus 2.5 volts. So this is V of 0 plus at t is equal to 0 plus. For let's write at a t greater than 0. At a t greater than 0, for t greater than 0, the same circuit will, but this capacitor will act like a voltage source, and a capacitor, and this will be a resistor. So this value of voltage source is 5 volts, and this is 1 by 4 farads, and this is 2 ohms, and this is also 2 ohms. So for t greater than 0, we'll write KVL equations. We'll apply KVL equations to this. So apply KVL equation. Let us consider this current as I of t. Apply KVL. When you apply KVL, what you'll get? You'll get minus 2i minus 5 minus 1 by c integral. 1 by c is 1 by 4 integral I dt minus 2 into I is equal to 0. This is the current direction, right? So you'll get 2 into I minus 5 minus 1 by 4, 1 by 1 by 4, 1 by c integral I dt minus 2i is equal to 0. So you'll get minus 4i minus 5 minus 4 integral I dt is equal to 0. This 4 will go to the numerator. So that's how you'll get it as, if you differentiate this equation, take minus to the right side and differentiate this equation. What will happen? 4 into di by dt plus 0. 5 differentiation is 0 plus 4 into I is equal to 0. So this is a differential equation. You can write it as divide by 4 di by dt, neglect this 0, it is I is equal to 0. So this is the differential equation corresponding to t greater than 0. So differential equation corresponding to t greater than 0 is di by dt plus I is equal to 0. So you just need to write its complementary function because you don't have a particular integral. Di by dt plus I is equal to 0. So what is its solution? Its solution is I is equal to IC, since IP is equal to 0 because RHS is 0. So you can write it as d plus 1 into I is equal to 0. So to find complementary function I complementary, consider m plus 1 auxiliary equation. So m is equal to minus 1. So you will get I complementary is equal to k into e power minus 1t. Therefore, total solution I is equal to I complementary k into e power minus t. So you need to find this k value. So solution is I is equal to k into e power minus t. Next we need to find k. To find k, substitute initial conditions. What is the initial condition? At t is equal to 0 plus I of 0 plus is equal to, at t is equal to 0 plus I of 0 plus is equal to minus 1.25 if you observe. So this is minus 1.25. I of 0 plus at t is equal to 0 plus is minus 1.25. Let's try to substitute that value. So this is minus 1.25. So what is I is equal to k into e power minus t. Substitute I is equal to minus 1.25 is equal to k into e power minus 0. Therefore, k is equal to minus 1.25. K is equal to minus 1.25. Therefore, let's write I is equal to, now I is equal to k into e power minus t. Therefore, I is equal to k value. What is k? Minus 1.25 into e power minus t. Minus 1.25 into e power minus t. So this is the value of I. But we are asked to find not I, we are asked to find v of t. We are asked to find, question is find v of t for t greater than 0. And what is v of t? V of t is 2 times of I of t. V of t is 2 times of I of t. Therefore, V of t is equal to 2 into I, or 2 into I of t. This is I of t. So that is 2 into 1.25 negative into e power minus t. Therefore, V of t is equal to, what is V of t is equal to? So 2.5 minus 2.5 into e power minus t for t greater than 0. This is the value of voltage for t greater than 0. So this is that value. V of t is equal to 2 minus 2.5. Augustus, good morning. Welcome to Unacademy. Minus 2.5 e power minus t is the voltage across the resistor that is asked. So this is one solution. Let's see how we have done this. The circuit is given like this, and here switch is at position A for a long time. Then it is moved to position B. Now when it is at position A, we have drawn a t is equal to 0 minus. T is equal to 0 minus is at position A. Therefore, the capacitor, because it is charged, will get open circuit and it will be charged to 5 volts. And when this switch is moved to point B, the capacitor will act as a voltage source, and therefore we will find I of 0 plus and V of 0 plus voltage. This voltage we have found V of 0 plus and I of 0 plus. Then for t greater than 0, this capacitor will act like a voltage source in series with a capacitor. So we have applied KVL equations and found the differential equation. Then once we got this differential equation, we tried to find its solution. Because you don't have RHS here, IP value is 0, and we tried to find the complementary function and then found the complete response equation. But you also need to find this K value. So we substitute at t is equal to 0 value of current minus 1.25, so you'll get the value of K as minus 1.25. Then you substitute back that K value here in this, so you'll get I of t without K, that is a complete response. Then by using V of t is equal to 2 into I of t. Why is it 2 into I of t? Because in the given question, see, this is the question, V of t is the voltage across resistor. So it is 2 into the current. So 2 into the current flowing through that. So the current flowing is minus 1.25 e power minus t. That's how you'll get minus 2.5 into e power minus t for t greater than 0. So let's also try to do one more question. Let us try to solve this question. The question is, for the network shown, find the current when the switch is opened at t is equal to 0. When switch is opened at t is equal to 0, find the current I of t. Find current I of t. And the circuit is given like this. We have a dependent source in this circuit. There is a voltage source, resistor, and a switch is connected like this. There is a dependent source with a capacitor of 4 microfarad and a parallel resistor. So let's write all these values. The given voltage source value is 100 volts. Switch is open, so the direction is given like this. And you have a 10 ohm resistor. This is a voltage current dependent voltage source plus 5i, and this is 4 microfarad, and this resistance is 10 ohms and the current is I of t. So let's try to find its solution. At t is equal to 0 minus, what is the position of the switch? At t is equal to 0 minus, that is just before that, at t is equal to 0 minus, the switch is closed. Because it is being opened, that means switch is opened at t is equal to 0 indicates at 0 minus switch is closed already. So switch is closed. Switch is closed. So let's try to draw that circuit. So this is resistor and switch is already closed. You have a dependent source with this capacitor, and this capacitor will become, let's try to draw it, open, and there is a resistance. So now let's try to write these values. This is plus minus 100 volts, 10 ohms, I of t, and this is again 10 plus minus 5 into I, and this is on. This is already on. So there is a flow of current I of t and the capacitor is open. So VC of 0 minus, you also need to find this voltage. Nikhil, good morning. Welcome to Unacademy and Network Analysis and Transmission Lines. So let's try to write first what is I of 0 minus. What is I of 0 minus? I of 0 minus is the current that is flowing in this circuit. So it is 100 by V by R. What is the resistance? Two resistors are present. So it is 100 by 10 plus 10 is 100 by 20. You'll get 5 amperes. Now let's try to find what is VC of 0 minus voltage across is equal to, it is 100 minus 100 volts minus 10 into I of 0 minus 5 into I of 0 minus. So this is equal to, this is the voltage, right? So it is 100 minus 10 into I of 0 minus. Next 5 into I of 0 minus. So it is 100 into 100 minus 10 into I of 0 minus 5 minus 5 into I of 0 minus 5. So this will give you 100 minus 50 minus 25 will give you 25 volts is VC of 0 minus. The VC of 0 minus is equal to 25 volts. Now let's, this is at t is equal to 0 minus, this is at t is equal to 0 minus. Now let's take t is equal to 0 plus case. At t is equal to 0 plus. Now let's try to draw that circuit once again. At t is equal to 0 plus, the switch is open. When the switch is open, you don't have the source, you only have this dependent source, and capacitor will act like a voltage source, and you have a resistor. So this is plus 5i plus minus, this is plus minus 25 volts, this is I of t and 10 ohms. So in this you need to find what is I of 0 plus. So I of 0 plus will be, so this is 25 plus 5 into I of 0 minus minus 10 into I of 0 plus is equal to 0. So I of 0 plus from this can be obtained as 5 amperes. I of 0 plus will be obtained as 5 amperes at t is equal to 0 plus. So at t is equal to 0 plus, you got I of 0 plus as 5 amperes. So how do you get that? Just write 10 into I of 0 plus is equal to 25 plus 5 into I of 0 minus. So this is 25 plus, so 25 plus 5 into I of 0 minus value. This is 5. So this is 5. So this is 50. 10 into I of 0 plus is equal to 50. So I of 0 plus will be equal to 50 by 10 will give you 5 amperes. So at t is equal to 0 plus, you'll get 5 amperes. So at t greater than 0, next. At t greater than 0, we need to find the value. So for this, for t greater than 0, you can take the same circuit, but this voltage source will be along with its capacitor, and you'll have this resistor. This is plus minus 5 into I, this is 25 volts, and this capacitor value is 24 microfarad. 4 microfarad, sorry, 4 microfarad. This is 10 ohms. The value of this current is I of t. So at t is equal to 0, if you try to write the equation, what is it you'll get? 5 di by dt at t is t greater than 0. What is that? 25 volts minus 1 by 4 into 10 power minus 6 microfarad into integral I dt from 0 to t plus 5i minus 10 into I is equal to 0. So 25, if you take this current as this direction, it is 25 minus 4 into 1 by c integral I dt, and this is minus plus, so plus plus 5 into I, and this is plus minus to take this current in this direction. So it is 25 minus 1 by c integral I dt plus 5i minus 10i is equal to 0. Differentiate this, you'll get 0 minus 1 10 power 6 by 4 into I plus 5 di by dt minus 10 di by dt is equal to 0. So what you'll get, 5i minus 10i minus 5i. So di by dt minus, we can write this as 5 di by dt minus 10 di by dt plus, you have one more term, minus 10 power 4 by, so this is minus 10 power 6 by 4 I is equal to 0. So you can write this as minus 5 di by dt minus 10 into 10 into 10 power 4. Let's write it something like this, into 4. 2 2s are 2 5s are 2 1s are 2 5s are 5 5s are 25. So you can write it as 5 di by dt. If I take common, minus 25 into 10 power 4 I is equal to 0. I can divide this by 5. So di by dt plus 5 into 10 power 4 into I is equal to 0. The same differential equation with RHS 0. Swarnasri, good morning. Welcome to Unacademy. Please everyone share this video, like this video, so that other students also get benefited out of this. So you have this differential equation. You can also write this differential equation as d plus 5 into 10 power 4 into I is equal to 0. Sorry. Yeah, this is d plus 5 into 10 power 4 into I is equal to 0. So what is its solution? I is equal to IC, I complementary. So how do you find this I complementary? So to find I complementary, so we'll take m plus 5 into 10 power 4 equal to 0. So m is equal to minus 5 into 10 power 4. Therefore, the solution will be I is equal to I complementary is equal to k into e power minus 5 into 10 power 4 t. So you got I is equal to k value, k into, you do not know k value, k into e power minus 5 into 10 power 4t. So next you need to find this k value. So to find k, you need to substitute the initial condition. What is that initial condition? At t is equal to 0, I of 0 plus value was 5 amperes if you observe. So this is, at t is equal to 0, I of 0 plus value is 5 amperes. So when this is 5 amperes, you need to find the value of k. So I is 5 is equal to k. You need to find e power minus 5 into 10 power 4 into t is 0. Therefore, k is equal to 5. So what is a complete solution? I is equal to 5 k value into e power minus 5 into 10 power 4 into t. So this is the complete solution of I for t greater than 0. For t greater than 0. 5 into e power minus 5 into 10 power 4 t. So this is how you'll solve the question. So let's see what we have done. Just once again, the given question is, yeah, this is the given question. You'll have a voltage source, a dependent source in series with a capacitor and a resistor. So at t is equal to 0 minus, the capacitor is fully charged, therefore it is open. Therefore voltage across the capacitor can be calculated by using this loop. It is 100 minus 10 minus, 100 Vc of 0 minus is equal to 100. So this is plus minus drop. Therefore 100 minus 10i, and this is plus minus. So it is minus 5 into I of 0 minus. So that's how you'll get the value of Vc as 25 volts. So I of 0 minus as 5 amperes and Vc of 0 plus 0 minus as 25 volts. So now let's take we have done what we have done at t0 minus. We have got I of 0 minus and vc of 0 minus. Then we have considered tc of 0 at t is equal to 0 plus. At t is equal to 0 plus, this capacitor will act as a voltage source. So this capacitor that you see here, this is fully charged in this case at t0 minus, and this starts acting like a voltage source at t0 plus. So 25. So you need to find the current in this case. So I of 0 plus. To find I of 0 plus, so you need 25. This is a voltage 25. This is minus plus minus plus. So 25 plus 5i. And this is plus minus. So 25 plus 5i minus 10 into I of 0 plus. That's what we need to find. So we do not know this 5i. So we need to take its initial condition I of 0 minus. Previously, what was the current? So I of 0 minus. So what is I of 0 minus in that case? We just got I of 0 minus as 5 amperes. So just substitute that 5 here, and if you simplify, you'll get I of 0 plus as 5 amperes. So after that, take the condition of t greater than 0, the capacitor and a voltage source. The capacitor will act as a voltage source along with this capacitor in series. Here you apply KVL. What is KVL? If you take this current direction, this is plus minus minus plus. So minus plus minus plus. 25 will be plus and 5i will also be plus. See, 25 is plus and 5i is also plus. And capacitor and voltage across capacitor and voltage across resistor are minus. So this is 10i minus, and this is also voltage across capacitor minus. So because you have got an integral equation, differentiate this. What we have we done? Differentiate with respect to t. When you differentiate with respect to 25, it is 0, and this is I have taken 10 power minus 6 to the numerator. It is 10 power 6 by 4 into integration differentiation will get cancelled, and you'll get I plus 5 into differentiation is di by dt minus 10 into differentiation is di by dt is equal to 0. Then after this, 5i minus 10 di by dt minus 10 power 4 by 6 it, 10 power 6 by 4 into I is equal to 0. I try to simplify these two. This is plus 5i di by dt plus 5 di by dt minus 10. So I'll get minus 5 di by dt. Minus, I have written this 10 power 6 as 10 power 10 into 10 into 10 power 4. And simplified and written as 25 into 10 power 4 I. And because you have a 5 here, I want to make this coefficient as 1, so I have taken divided it by 5. So I'll get 25 by 5 will give me 5 into 10 power 4 I. So this is the differential equation with RHS as 0. Therefore the complementary function is can be obtained, but the particular integral will be 0 again. So I have not written this particular integral part. So I tried to find the complementary function by taking the auxiliary equation. I got it as k into e power 5 into 10 power 4 t. So once I got this equation of current in terms of K and T, I tried to find K value. What I have done at T is equal to 0, I of 0 plus is 5 amperes. So substitute I is equal to 5. This you have I, so I have substituted 5. K value is what we need to find, and T is equal to 0. Anything power 0 is 1, so it is K is equal to 5. So is I is equal to 5 into e power 5 into 10 power 4 T is the required current value for t greater than 0. So this is how you will determine the value of the current that is asked in the question. The question was that, right? So what was the question? Just look at that. Yeah. When switch is open, find the current I of t. This is the current that was asked. There is another question. Let's try to take this question and try to solve it. Let's take one more question. The question is, in the network, an exponential voltage in the network an exponential voltage. What is the exponential voltage? 4 into e power minus 5t. 4 into e power minus 5t. An exponential voltage. An exponential voltage is given. So an exponential voltage 4 into e power minus 5t is applied at t is equal to 0. At t is equal to 0. So find the expression of current. Find expression of current assuming 0 voltage across capacitor at t is equal to 0. This is one of the questions taken from one of the textbooks of Ravi Shah Singh. So and the circuit is given like this. This is the circuit, and you have a resistor and a capacitor given to us, and this value of capacitor is given as 1 farad and value of the resistor is zero point 0.2 ohms. Switch is closed and current is I of t, and this is 4 into e power minus 5t. This is the given question. So let's try to write this. Very simple. So at t is equal to 0 minus, it is already given that the 0 voltage across capacitor at t is equal to 0 indicates it is an uncharged capacitor. It is an uncharged cap. So at t0 minus, switch is open. So let's try to write that. When the switch is open, see this switch is open. So this is 1 farad and I of 0 minus zero point 0.2 ohms. Switch is off and the input is 4 into e power minus 5t. So what is current value at t is equal to 0 minus? This will obviously be 0 amperes because it is open. The switch is open, therefore I of 0 minus is equal to 0 amperes. What is the voltage across the capacitor? It is 0 volts. Voltage across capacitor is equal to 0 volts. Now let's try to take a t is equal to 0 plus. So at t is equal to 0 plus, so you have a voltage source, so you have a voltage source and switch is closed. You have a resistor and capacitor does not allow sudden change of voltage, so it will be a short circuit. Similarly, vc of 0 plus is also equal to 0. Resistor value is 0.2 ohms. It is 4 into e power minus 5t. There will be a flow of current now. So what is I of 0 plus is equal to 4 into e power minus 5t by 0.2 is 40 by 2 into e power minus 5t. At t is equal to 0, anything power 0 is 1. So it is 40 by 2 is 20 amperes. So I of 0 plus value. So I of 0 plus value will be 20 amperes. So because this is at t is equal to 0 plus, you can just take this value as anything power 0, t is equal to 0, this value will be 1. So 40 by 2 will give you 20 amperes. So this is the value of current at t is equal to 0 plus, and V of 0 plus value is already 0 volts because it is a short circuit. Now let's try to apply at a t greater than 0. Let's try to find. So you have a voltage source which is on and a resistor, also a capacitor which is uncharged. This value of voltage is e power 4 into e power minus 5t, 0.2 ohms, and this value of this is 1 farad and current is I of t. Therefore, if you apply KVL, apply Kirchhoff voltage law. So it is 4 into e power minus 5t minus zero point 0.2 into I of t minus 1 by c integral I of t dt is equal to 0. 1 by c value is 1. So you can write 4 into e power minus 5t is equal to integral I of t dt plus 0.2 I of t. So this is an integral equation. So differentiate with respect to t. So you'll get 4 into minus 5 into e power minus 5t. Differentiation of e power minus at minus a into e power minus at. So it is minus a into e power minus at. Integral differentiation will gets cancelled. So you'll get I of t plus 0.2 di of t by dt. 0.2 di of t by dt. So let's try to write this as 0.2 di by dt, di of t by dt plus I of t is equal to minus 20 into e power minus 5t. So let's try to divide this equation by 0.2. So we'll get di of t by dt plus 1 by 0.2 I of t. 1 by 0.2 is 5. So minus 20 by 0.2 into e power minus 5t. What is 1 by 0.2? It is 10 by 2 is 5. So 1 by 0.2 can be written as 5. So this is what is the differential equation that we got just now. So first we have calculated for t0 minus I of 0 minus 0, Vc of 0 minus 0, and then at t0 plus I of 0 plus is 20, V of 0 plus is 0. Capacitor does not allow sudden change of voltage. So from this we have taken t greater than 0. So this is what we got it. So differential equation will continue to do that. So di of t by dt plus 5 into I of t is equal to 100 into e power minus 5t. 1 by 0.2, we just take it, you'll get into 5. So this is d plus 5 into I of t is equal to minus 100 e power minus 5t. Minus 100 e power minus 5t. Just try to take that. D plus 5 into I of t is equal to minus 100 e power minus 5t. So to this you'll get a solution. There is a solution I is equal to I complementary plus I particular integral. What is I complementary plus I particular integral? So to find I complementary, we'll find I complementary as, consider the auxiliary equation f, this one, f of m is equal to 0. So m is equal to minus 5. Therefore I complementary function will be equal to k into e power minus 5t. Next we will find particular integral. To find I particular integral, we'll take the same equation. I particular is equal to minus 100 into e power minus 5t by d plus 5. Here you have d is equal to a. What is d is equal to e power at minus 5? Substitute d is equal to a. So when you substitute d is equal to a, you will get it as 0 in the denominator. So you will get Ip is equal to minus 100 into e power minus 5t by, if you just do this, you'll get a 0, infinity denominator. So in such cases, what you have to do is, you have to differentiate it so that you'll get Ip is equal to minus 100 into t into e power minus 5t. So you got Ic and Ip. So I is equal to I complementary plus I particular integral. So what is I is equal to I complementary? I complementary is k into e power minus 5t plus I particular integral is minus 100t into e power minus 5t. Minus 100t into e power minus 5t. So I'll get it as I is equal to minus 100t into e power minus 5t plus k into e power minus 5t. That's how you'll get it, the value of I. Next you need to find the value of, to find value of k. What do you substitute? At t is equal to 0, I of 0 plus value is 20 amperes that we got. Just look at this. We got 20 amperes. I of 0 plus 20 amperes. So 20 amperes, substitute it here. So 20 is equal to minus 100 into t is 0, e power minus 5 into 0 plus k into e power minus 5 into 0. So this will give you k is equal to 20. So k is equal to 20. Therefore, what is I is equal to I of t is equal to minus 100t into e power minus 5t plus k is 20 into e power minus 5t. This is how you will determine the value of I of t for t greater than 0. That is the question asked. Let us see what have we done. So this is the question wherein the input voltage is given as 4 into e power minus 5t and resistor value is 0.2 and we have capacitor value as 1 farad, capacitor value as 1 farad. So we have taken a t is equal to 0 minus, so when t is equal to 0 minus, the switch is open. When the switch is open, when the switch is open, then this current is 0, I of 0 minus is 0 and V of 0 minus is also 0. When this value is 0, you have to consider then t0 minus. When t0 minus, in t0 minus, when t is at t0 minus, we have got I of 0 minus as 0 and V of 0 minus as 0. At t0 plus, you got I of 0 plus is equal to 20 amperes. When you substitute that, at t is equal to this value of 0, anything power 0 is 1. So you will obtain this as I of 0 plus as 20 amperes and V of 0 plus as 0 volts. So when you consider that, you need to then consider what is at a t greater than 0. Just try to consider that t greater than 0. Then you apply t greater than 0. When you apply t greater than 0, apply KVL, you'll get 4 into e power minus 5t minus 0.2 I of t plus 1 by c integral I of t dt is equal to 0. So you'll get 4 into this. Because this is a differential equation, you are trying to make this as differential equation by differentiating it. When you make differential equations, you'll get di of t by dt plus 1 by 0.2 into I of t is equal to minus 20 by 0.2 e power minus 5t. So that's how you'll get a differential equation like d plus 5 into I of t is equal to minus 100 into e power minus 5t. So I complementary function is obtained by taking the auxiliary equation f of m is equal to m plus 5 is equal to 0. This one, when you try to find the complementary function and substitute d is equal to minus 5, this will become 0. Then you have to take particular integral is equal to t into 1 by f dash of d into e power minus 5t. So that will give you t into 1 by differentiation of d. This is 5 into e power minus 5 into t. E power minus 5 into t into 100. So this is how you'll get minus 100t. So you'll get minus 100t into e power minus 5t. Minus 100t into e power minus 5t. So you'll take the complementary function and particular integral and try to find the value of k by substituting the initial conditions, and you'll get I of t value. So that's how you find these values. And thank you once again for everyone for joining me this session on uh, response of RC series circuit. And we have Creatrix Gate, Unacademy Gate, Unacademy SSCJ, Unacademy Computer Science, Unacademy Gate, Unacademy Foundations, Unacademy Gate Questions, Unacademy Pathshala, Electrical Junction, and also Unacademy Semester Exams. Please like this video, share this video, use my referral code, subscribe to our channel, and click on this bell icon to get more notification of my classes, and get 10% off on by using my code YSK10 on your next Unacademy subscription. Thank you once again. Thank you all. Before I end, I would like to introduce once again this starting new batches in Unacademy, that is Evolve Gate 2022 and Ascent Gate 2023. We starting from 28th of December. So we have top educators of Unacademy in various streams. So hurry up and get subscription to Unacademy as soon as possible. So thank you all. Thank you once again for joining me today.